So far we've been discussing TCP IP addressing, and in reality we've been looking at Ipv4 addressing. Ipv4 consisted of 32-bit binary addresses, initially in a classful system, then it switched to classless. One of the reasons they switched to classless is because the limitations of the address space. If we jump from decimal point to decimal point, we don't have nearly the flexibility that was required on today's networks. But even changing to the classless system still really didn't get it done. You know, the 32-bit IP address itself, or the address space itself, provides a limited number of IP addresses. That should be 2 to the 32nd power, not 232. So it's roughly around 4.3 billion separate addresses. Now, when the inventors and developers of TCP IP originally came up with it, that seemed like it would be more than enough. But of course, the internet has launched and taken off probably beyond anybody's imagination, and very quickly, at the turn of the millennium, we began to realize that this was certainly not going to be enough. In fact, actually the late 90s was when they started to develop Ipv6 because of the address space limitations. And they knew at some point they were going to run out of Ipv4 addresses. And at that point, we were going to have a different answer. And like I said, the answer at one part was switching to classless and then starting to use private IP addresses to limit the number of public addresses that an organization would have, but those couldn't completely solve the problem. And so at this point, we have completely run out of public Ipv4 addresses, and thus the need for a next generation TCP IP or TCP IP version 6. So in the late 90s, when the developers of TCP IP realized the limitations of the address space, they began to develop Ipv6, the next generation of TCP IP. Again, they had already tried other methods. The classes proved to really not be very flexible, and so they switched away from that, went to classless. Class A, Class B addresses were almost nearly depleted. Going to private allowed us to extend their use, but not as much as would be necessary. Within the Class A and the Class B blocks, you had huge numbers of unassigned and unused addresses. No organizations have 16 million addresses, for instance, that they would need for a Class A address. So as TCP IP version 6, Ipv6 was designed, it was being designed with these limitations in mind. And so that's going to be something important to recognize, and it's actually fairly easy to see. As we start looking at the advantages and features of Ipv6, we can actually see the stark contrast between Ipv6 and Ipv4. So Ipv6, also known as the next generation TCP IP, is the successor to Ipv4. At the very root of the protocol, we have a fundamental change, and that is a switch to 128-bit binary address space. So from 32 to 128-bit. Now, some of us look at that and say, oh, wow, okay, that's 4 times the number of addresses. That's forgetting how binary works. That's not 4 times. We're talking about 2 to the 32nd power in comparison with 2 to the 128th power. This is a massive number of IP addresses. It is inconceivable that we would ever even come close to depleting the Ipv6 addressing pool. And I know the same thing was probably said about Ipv4, but we understand, how often these IP addresses are used and what they're going to be necessary for. This is, it's literally inconceivable. 10 to the 38th power, I believe, is the number of available IP addresses that this would give us. It's just a huge, huge number. The calculator usually will stop functioning if you try to plug that number into it. In addition to the change in address space and increase in the number of addresses, it also includes new efficiency features. Some of the headers are simplified in Ipv6. non-essential information is moved to optional headers. Plus, we have information in the headers that will provide us with quality of service. Quality of service is the prioritization of certain types of data over others, and that's really necessary when we start dealing with voice over IP, audio-video streaming on top of networks that are being used for other types of data transfer. Another efficiency feature would be the integration of IPsec security as an inherent part of the protocol rather than something that the operating system would be responsible for managing. So there's some changes there. It is going to be incompatible with IPv4. These IPv6 in order to use it on an IPv4 network, you would have to have some sort of translational technologies, transitional technologies as they're called. It is possible to do, and actually a number of them are going to be supported and some installed even by default on the Windows operating systems. But natively, it's going to be incompatible with the older protocol. But while incompatible, we will see both installed in the latest versions of Windows. Really, it started with Windows Vista and Windows Server 2008 on through the current versions of Windows. You have both IPv4 and IPv6 in use. One of the most noticeable differences between IPv4 and IPv6 is going to be the address itself. Now, before we talk about the formatting of the addresses, we should note that there are multiple types of addresses for IPv6. There are global addresses, also called global unicast, which is a publicly routable IPv6 address. Now, up till just a couple of years ago, it was pretty rare that you would ever see these, but now that we have completely run out of IPv4 addresses, it's actually fairly common, depending on where you're at, to see your ISP has now started giving out IPv6 addresses. I know that that's something that I will see through my service provider at home and at some businesses. That's called a global unicast address. You have a link local address. Link local addresses are used and automatically generated by each individual client. They start with, and we'll see this in a minute, but they start with the prefix FE80. It's something that's generated on the local link. It's really only for local link communication. It's sort of the equivalent of the IPv4 addresses in Windows. I don't believe we've mentioned that before. That's a 169.254 address that's generated if you're having a problem communicating with the DHCP server. So you have global unicast, link local, and then you also have local unicast, which were originally known as site local addresses. Those are like private IPv4 addresses. The IPv6 address is a 128-bit binary number, and if you're going to function on an IPv6 network, then we would have to have this type of address. Okay, being a 128-bit binary number, it's going to be fairly large. And so what we'll see is that that number is now written in what is called colon hexadecimal, separated into 8 groups of 4 hexadecimal digits. Essentially, you can group 4 binary digits into a single hexadecimal digit, and so that's going to allow us to cut down on the size of these addresses. And we'll look at the address and talk about some of the other things, some of the other ways in which we can shorten it. Just like IPv4, you still have a distinction between network segments and host segments. It's just going to be a little bit different because we don't ever see the subnet mask written out. It's always going to be that slash notation that we saw with CIDR. And typically, it is /64, so it's just dividing the number down the middle. Of course, IPv6, like any other numerical addresses, this is going to be easier if we just take a look at it. And so we're going to do a little bit of a demo. We'll get on our Windows 7 system and look at the IPv6 addresses that are assigned to it. Okay, so we're on our Windows 7 system, and again, starting with Windows Vista, IPv6 has been installed by default. All right, so we'll go into the command prompt, and if we do an ipconfig, we will see a link local IPv6 address here. Again, the link local is very much like the 169.254 addresses. They're a little bit more functional and IPv4 169.254 just was there for troubleshooting purposes. This is actually used. In fact, if I have other systems to communicate with on the local network, they will most likely respond with that IPv6 address. So they are always going to start with FE80. Now, I don't have the ability to show you a public IPv6 address, but a global Unicast address will always be 2001 in that first section. Let's do an ipconfig all. If we get any more information here, usually we'll get some information about it being a DHCP v6 client. If DHCP is enabled there. Let's try to distinguish between these, though. Okay, so what we have is a groups of 4, FE80, B058, 1D. Okay, so it's groups of 4, and they are hexadecimal digits. They will be separated by colons. Now, what I'd like to notice here is that this looks and could be potentially confused with a MAC address. Okay, if I really spend any time looking at them at all, I can see that there are some significant differences, so that's what I'd like to point out. The MAC address always uses dashes. The IPv6 address uses colons. Now, the other thing we could say is that the IPv6 address is 4 digits, and the MAC address is always 2. That is true. However, what we're not seeing here is that if there are leading zeros, okay, so for instance, if this was 0080, it could just be written as 80. You can eliminate any of the leading zeros in any of the groups of 4. If you have multiple groups of zeros, then we can eliminate them all, and that's where we have our little double colons there. All right, and so you can only use double colons once in the address, because otherwise I would have no way of knowing how many zeros had been compressed. They call both of those zero compression, and it's just to shorten the address. So you may see addresses that are much shorter. The other thing you'll see at the end, which I had mentioned, was this percentage. Percentage 11, it's called a zone ID, or a zone ID. And it's something that's automatically generated by the system. You don't have to configure that. But it's, that is something that you will see. It's a way for the system to identify a binding of an address to a particular network card. Let's go in here and just look at how we would configure an IPv6 address. Go to the properties and TCP Ipv6 properties. And so we either say that we want to obtain one automatically, or I want to use the following address. And at that point, I can type in an address, and I would just go like that, and then double colons maybe, and we could just make something up here. I mean, obviously, if I'm on a real network, I'm not going to be making it up. Okay? The subnet prefix link 64, the default gateway, the DNS servers, and if we do that, yeah, that's what I figured. If we do that, then we are going to have set a static address. If you find yourself using IPv6, what you are most likely going to have is DHCP configured. It would be very unlikely that I would be going in there and manually configuring IP addresses. The same as it's unlikely that I'm going to manually configure IPv4 addresses on client workstations, because it's too prone to error. So Windows servers can function as a DHCP v6 server and can automatically assign those addresses. So a real purpose for coming in here and showing you this was just to see that this is enabled by default, and to look at the general format of an IPv6 address.